I think there's two people, right? Bhupesh and Nishika. Hi, Bhupesh and Nishika. Have you attended this session before, or is this the first time?
I have attended this before, sir.
Okay, you attended it before. I think you were there in the last class. Were you there in the last class, Nishika, when we talked about?
Yes, sir.
Okay. I recollect. So you are in 11th class, right? So
Yes, sir.
very good, very good. And Bhupesh, have you? Is this your first class, or have you attended it before?
Sir, this is the first class of me.
This is your first class. Okay. Can you introduce about yourself a little bit? Like which class you are from, which board, CBSE or state board? Yeah.
Sir, I am studying 12th standard and I have state board, sir.
12th standard state board. Very good. Very good. You are from which place? Which location?
Sir, from Coimbatore, Veliyangadu, sir.
Coimbatore, Velliyangadu. Very good. Very good.
Thank you, sir.
And yeah.
Yeah, what is your name? Velingad Bhai, what is your name?
Sir, Bhubesh Kumar.
Oh, Bhupesh. I'm also from Velingad.
Oh,
Yes, sir.
That's my native, Radha. In fact,
I thought it's near, is it near Karamadai? Your native is near Karamadai, right?
Yes, yes. Of course, I
So
don't stay there.
Velliyangadu is.
Nowadays, I stay in.
Yeah.
Anyway, nice talking to you, Bhupesh. Anyway, good.
Thank you, sir.
Right. Yeah. I think since Nishka was there in the last class, so and Bhupesh, even though it is first class, you are in 12th. So உங்களுக்கு வந்து I think ரெண்டு பேருமே தமிழ் தான் இல்லையா? Shall I speak in English or Tamil? எது கம்ஃபர்டபுளா இருக்கும் உங்களுக்கு?
சார் எதெல்லாம்னாலும் ஓகேங்க சார்.
ஓகேவா? சரி சரி நான் மிக்ஸ்டா பேசுறேன். ஓகே
ஓகேங்க சார்.
ஓகே ரைட். Right. So it's already time. So let's get started. So other people may join, but yeah, we'll get started. So number last class we were looking at conjugates and modulus. Okay, so I want to continue with it now. So it's a new student, G Tamil. It's like some TV channel, Z channel. Hi. Hello. G Tamil, can you tell your name and whether you have attended any max class before, or is this your first class? I don't hear anything from G. Okay. So I want to know whether you are in state board or CBSE, or you are in 11th or 12th. To know that before I can plan my class. So G Tamil, are you hearing me? Okay. So we will continue with some more problems on conjugates and modulus right now. And then we will go to other topics such as
திருநெல்வேலியில் அம்பாசமுத்திரம். அம்பாசமுத்திரம் பாட்டி வீட்டு அம்மாவோட பாட்டி வீட்டு. அம்மாவோட பாட்டி போகணும்னா இப்போ 6th இருந்து 12th வரைக்கும் அம்பாசமுத்திரம் விக்ரமசிங்கம். 5th ஸ்டாண்டர்ட் நான் 5th படிக்கும்போது 5th ஸ்டாண்டர்ட் படிக்கிறேன். 12th வரைக்கும் படிச்சு காலேஜ். 10th என்ன மார்க் வாங்குவீங்க? 10th வந்து 332 தான். 12th 432. அவுட் ஆஃப் 6th ஸ்டாண்டர்ட். இந்த ஆர்பிஎஸ் கவுன்சிலிங். ஏன் கவுன்சிலிங்ல வந்து என்ன பிரான்ச்? மெக்கானிக்கல். இந்த ஹாஸ்டல் இருக்கீங்களா? இல்ல பாடி தான். இது டெய்லி போய் எவ்வளவு தூரம் வந்து ஸ்கூல் பஸ்ல போய் வந்துட்டேன். சும்மா போய் அது 1 hour டிராவல் ஆகும். என்ன ஃபீஸ் சார்ஜ் பண்றாங்க? ஃபீஸ் ஃபர்ஸ்ட் கிராஜுவேட் எனக்கு ஃபர்ஸ்ட் இயர் டிஎன்ஏல கவுன்சிலிங் வந்தனால அமௌண்ட் 15,000 மைனஸ். அப்புறம் ஃபர்ஸ்ட் கிராஜுவேட் 25,000 மைனஸ். போக டோட்டல் 35 இயர்லி. ஃபர்ஸ்ட் இயர் மட்டும் 15,000 அட்மிஷனுக்கு சேர்த்து 50,000. அடுத்த வருஷம் 35. அம்மா இங்க ஒர்க் பண்றாங்களா? அம்மா வந்து பிடி அந்த பிடில அந்த தொழிற்சாலை இருக்கா? அந்த பிடி தொழில். தாத்தா என்ன பண்றாங்க? தாத்தா பாட்டி வயசாயிடுச்சு. அம்மா நீங்க பாட்டி இப்ப நீங்க மாட்டீங்க. இப்ப இங்க இருக்கவங்க அப்பாவோட பாட்டி, அப்பாவோட அத்தை, அம்மாவோட அத்தை, அப்பாவோட அத்தை அம்மாவுக்கு சரி. அப்பாவோட தாத்தா இல்ல. தாத்தா இங்க இருக்கு. அப்பாவோட தாத்தா இருக்காங்க, அம்மாவோட தாத்தா இல்ல. ஓ, அம்மாவோட தாத்தாவோட தங்கச்சி இல்ல. சரி, அப்பாவோட தாத்தாவோட அக்கா. அந்த தாத்தா இல்ல. அவங்க இந்த தாத்தா இருக்காங்க, அப்பாவோட அப்பா இருக்காங்க. இங்க இல்ல, அவங்க பழனியில. பாட்டு மாதிரி ஞாபகம் இல்ல. பாட்டு தெரியும், வீட்டுல போட்டதுதான் தெரியும். ரொம்ப இத்தனை வருஷம் அங்கே தெரியும். அதான் எனக்கு தெரியும். So we help ஒரு குழந்தைகளை டச் பண்ணிருக்கோம். கோச்சிங் ஹெல்ப் புக்ஸ் கொடுப்போம். கொடுத்துருக்கோம். அது நம்மளுக்கு ஸ்பான்சர் வச்சுருக்கோம். ஒரு 5 பேருக்கு சப்போர்ட் பண்ணலான்னு சொல்லி கேட்டேன். அதுக்கு நான் 5 பேர் கொடுத்துட்டேன். பட் தட் டசன்ட் மேட்டர். ஸோ work, small help I can do, big help, small help I can do. Make use of the area. That is the idea. Because இந்த வீட்டில் we have about 1000 missions engineering and அது ஒரு சண்டே வந்து இந்த பாட்டி தேவையான எடுத்துப்போம். இது ஒரு 10,000 புக்கு. 10,000 புக்கு இங்கேருந்து போயிருக்கு. இன்னொரு 1000 புக்கு அதெல்லாம் போயிருக்கும், போயிட்டே இருக்கும். சரிங்களா? அதுதான் அது வந்து நீங்கள் ஒரு சண்டே வந்து சண்டே கம்மியில் இதே மாதிரி தான் கூட்டிகிட்டு கூட்டாமல் இருக்கும். இப்போ நீங்க சொன்னது எல்லாமே, அதாவது உங்க பேரு ஜெயமுக, அம்மா பேர் தானே அந்த அட்ரஸ் பாட்டியார் மதர் லிவிங் அப்படிலாம் போட்டு ஸ்கூல் நீங்க படிங்க. அந்த இடம் அம்பாசமுத்திரத்தில் எந்த ஸ்கூல்? அம்பாசமுத்திரத்துல விக்ரமசிங்கம் பாவனா போற வழியில அம்பாசமுத்திரத்தை அடுத்த பிஎல்டபிள்யூ அது போட்டு இப்போ ஆர்பிஎஸ்ல மெக்கானிக். அப்பா இல்லைங்கிறது போதும். அவ்வளோதான். என்ன சொல்றோமோ வேற ஏதாவது எக்ஸ்ட்ரா ஏதாவது சொல்லணும் உங்களுடைய அவார்டு வாங்கிருந்தா ஸ்பெஷாலிட்டி ஆஃப் டே ஹோட்டல் அதனால தான் எங்களுடைய அந்த PDF படிச்சு பாருங்க. என்ன பண்ணுவாங்க அதே தான். நெக்ஸ்ட் ரவுண்ட் ஏதாவது ஒரு சப்போர்ட் கொடுக்குறேன்னு சொல்லி வருவாங்க. என்னாச்சு? ஏன் ஆஃப்லைன் வந்துருச்சு? ஒரு நிமிஷம் இருங்க.
Yes, sir.
Okay, Sumit says yes. What about others? Rupesh or Nishika or G? G, what is your name? How can I call you? G, is that your name? G Tamil? G Tamil.
Sir, for inequality, triangle inequality, we will put less than or equal to Z1 plus Z2 போடுவோம் sir.
Z1 plus Z2, this is not equal to modulus of Z1 mod plus Z2 is not equal to modulus of Z1 plus Z2. What is actually true is Z1 plus Z2 modulus will be less than.
என்ன சொன்னேன்? I'll give my card.
That is because you would have seen in vectors, right? So if you represent Z1 as one vector, we were in this, right? So this is your modulus. So this is one complex number. I'll put another diagram here. Let us say this is Z1. Let's say this is Z2. Okay. So this is your mod of Z1. This is your mod of Z2. Okay. Mod of Z1 plus Z2 will be, this will be the sum of the x coordinates, which will be somewhere here. Sum of the y coordinates will be somewhere here. It is like a parallelogram. It will go like this. Okay. So Z1 plus Z2 will be here. Because if you add the x coordinate of x1 is Z1 and x coordinate of Z2, this is what you will get. X coordinate of Z1 will be something here. And similarly y coordinate. Then mod of Z1, Z2 is going to be this. Okay. So this is your Z1 and this is your Z2. And this is your mod of Z1 plus Z2. So in a triangle, it forms a triangle, you see. So in a triangle, we know that the biggest side will be less than or equal to the sum of the other two sides. Right? So that is what I have written. Z1 plus Z2, mod of Z1 plus Z2 will be less than or equal to mod of Z1 plus mod of Z2. Similarly, if you put, minus, okay, mod of Z1 minus Z2 will be greater than or equal to mod of Z1 minus mod of Z2. Okay. And then again, mod of Z1 into, sorry, let's put like mod of Z1 Z2 equal to mod of Z1 mod of Z2. Is this true? Anybody?
Yes, sir, it is true.
Okay. Sum, so you have to be careful, okay, when you are summing up two modulus, but for multiplication and division, mod of Z1 by Z2 is equal to mod of Z1 divided by mod of Z2. Okay. So these are the properties. We saw them all last class itself. Since there are a few new people, I repeated them. Okay. Okay. With these properties and our understanding of modulus and conjugate, we will do a few problems now. I'm putting as 11 because last class we did up to problem number 10. Okay. Now, if it's given that mod of Z equal to 3, then let us find the range of mod of 6 plus 8i. 6 mod of Z plus 6 minus 8i. Okay. So it's given that mod of Z equal to 3, and we need to find the range of mod of Z plus 6 minus 8i. Okay. I'll do this problem, and I will let you do another problem. If you know this problem, you can do it parallelly. Okay. But I will explain it now. Okay. So now mod of, we just now saw, right? The 6 plus 8a is, let us put a bracket here. So this is like your Z1 and this is like your Z2. Okay. There are two complex numbers here. Now mod of Z plus 6 plus 8i, we just know saw like properties of modulus, that this will be less than or equal to, okay, modulus of Z1 plus Z2 is less than or equal to modulus of Z plus modulus of Z1 plus Z2. So I am just applying that property here, and now this will therefore be less than or equal to, we know the value of modulus of Z, which is 3, and what is the modulus of this 6 minus 8i? We can calculate the modulus of this value 6 minus 8i, square root of 6 square plus 8 square, right? Which is, this is equal to 36, yeah, plus 6400. So square root is 10. So this will be less than or equal to 3 plus 10, less than or equal to 13. Similarly, we saw another property. So we can write this as Z minus 8i minus 6. I'm just manipulating a little bit. That's all. Okay. So this comes like this, right? So modulus of z minus modulus of 8i minus z minus 8i minus 6. So that will be, where you put minus now. Minus 8i plus 6, right? Z minus 8i plus 6. So I just put it in the another way. And this will be, means we saw that modulus of z1 minus z2 is greater than or equal to modulus of z1 minus modulus of z2. Whole modulus 1, okay? Because they're all talking about modulus. There's no negative in the modulus, okay? So now let us calculate this. This will be greater than or equal to, so modulus of z is 3. It's given, right? 3. And minus, this is 10. Okay. Therefore, 3 minus 10 is minus 7. So modulus is 7. Therefore, this modulus of z plus 6 minus 8i is greater than or equal to 7 and less than or equal to 13. So we have proved that. That is what they want us to prove. Okay, it is in the range 7 to 13. Okay, the simple application of the properties of modulus, we can get this. Okay. I'm writing it in another way. Okay. So I'm going to ask you to do one problem, similar problem. Okay. These problems are there in your book only. Okay. So I'm just taking from your book itself. If you can do all these problems in your book, you can comfortably get a good mark in your JE. Okay. So you will not be able to top it, but okay, it will give you a good mark, which will be enough for you to get into other good colleges. Okay. But this is the basic. First, you should all be very comfortable with all the problems in your book. Okay. After that, there are some additional problems that you can do if you are, if you want to get into IIT. Even that, those are not very hard. If you understand all these concepts, it's just the application of concepts. Yeah. Yeah. So you already proved it, right? But let me give a couple of minutes for other people to do. If mod of z equal to 1, show that mod of z square minus 3 is less than or equal to 4. So who are all able to do and doing, please raise your hands. So I know that you are able to do and you're doing it. Okay, I see that everybody is able to do and yeah, doing it. Now, if you have done completed, you please raise your hands. Okay, so I'll wait until some of you, at least some of you, do complete it. Okay, Nishika has done it. Good. Okay, Sumit has done it. Good. Okay. I'm seeing some messages. So Sumit completed. G Tamil was also done. Okay. Rupesh. Very good. So looks like most of you have done. So I'll tell now. Okay. You can verify. You can put your hands down now. Okay. Um, since it is given that mod of z equal to 1, what you should do is you should calculate mod of z square is there in this expression. So we have to calculate mod of z square. What property did we see? Mod of z square equal to mod of z whole square. Therefore, this is equal to 1. Okay. Therefore, so we see that z square, so less than or equal to property is asked. So we have to use this property plus minus 3. Okay. So this is the property mod of z square plus minus 3 is equal to mod of z square plus mod of 3. So what is mod of z square? 1 plus 3. It is less than or equal to 4. That's all. If they had asked what is that greater than or equal to what, so then we will put it as minus. Okay, z square minus whatever value given. So it will be z square minus 3. So here we will put whole mod of z square minus mod of 3, like that. Okay, last problem we did that. In this problem they are not asked. So this is the end of this problem. I hope everybody understood, right? I think Krishnaveni, did you also do it? You didn't raise your hand. Krishnaveni? Okay. Let's see if there is another problem in that. So using the properties only, there is another problem. Let's do this problem. Not copying. Okay. Now here mod of, there are 3 complex numbers, z1, z2, z3. And mod of z1 equal to 1, mod of z2 equal to 2, mod of z3 is given equal to 3. And mod of z1 plus z2 plus z3 is also given. Now they want you to evaluate this expression. Mod of 9 z1 z2 plus 4 z2 z3 plus z2 z3. So I think this should be z3 z1. Okay. It's a little tricky, but again, yes, it's similar only using the properties of modulus. So I'll give you a clue. Okay. Since they are given Z1, Z2, Z2, Z3, Z1, Z3. Okay. So those can be written as Z1, Z2, Z3 whole divided by, Z3 and so on. Okay. So that is the clue. Okay. So you can represent Z1, Z2 equal to Z1, Z2, Z3 divided by Z3. Yeah. So like that you can represent the others also. So that is how you can do it. Okay. Please do it. I'll give you some time. If you can do it well and good, and then I will explain it after some time. Yeah, if anybody has done it, please raise your hands. Okay, good. We'll wait for another minute for other people to do. Okay. And one more property of Krishnaveni and also done it. Very good. Sumit has also done it. Super. Here, one more property of modulus is and conjugate that is needed for this problem, and that is a modulus into its conjugate is equal to mod square. Okay. That is because we saw already that in terms of graphical representation, suppose this is Z, this is mod of, sorry, a conjugate of Z. So since it is just a conjugate, that y has become minus y, that's all. Therefore, this mod will be same. This is Z conjugate mod and this is Z mod. They are equal. You can see from that diagram. Okay. Therefore, Z into Z mod, so that will become Z mod whole square. Okay. So you can also see that, no, this is the approach we use, no, x plus iy into x minus iy equal to, if you multiply, you will get it as x square plus y square, so which is equal to mod of z or z conjugate. So both the numbers z and z conjugate both have the same modulus, and the value is x square plus y square. So that is why the product of the two, so you can see from the formula, right? Okay. Correct. So, okay, looks like a lot of people have done it. So I'm going to explain this problem. So mod of 9 z1 z2 plus 4 z2 z3 plus z1 z3 is what we have to calculate. Like I said, no, so you can put it as 9 z1 z2 z3 by z3 okay, and therefore this can be written as z1 z2 z3 into so the given expression can be written in this manner. Okay, so now we know that mod of some z1 into z2, I'm considering z1 z2 z3 as one number, and this 9 by z3 plus 4 by z1 plus 1 by z2 as another number. So this can be written as mod of z1 z2 z3 into mod of okay. And now we know that mod of z1 z2 z3 equal to mod of z1 into mod of z2 into mod of z3, right? Into now this one 9 by z3 can be written as 1 by z3 equal to, so we can write like this, z3 conjugate equal to z3 mod square. Therefore 1 by z3 will be z3 conjugate by z3. Simple rewriting of that this expression, you get 1 by z3 equal to z3 conjugate by z3 mod square. So 9 z3 conjugate by, because these are the known values, we have these mod and these are given to us. So okay, so now we know that z1 z2 z3 mods are given, right? 1 2 and 3 respectively, 1 into 2 into 3, so that is 6 times mod of, so 9 z3 conjugate by, now z3 square is what? So mod of z3 is given as 3, so that will become by 9. 4 z1 by z1 conjugate. One. Oh my god, I think something wrong. 1 minute. I think there's something wrong in the way I have written the problem, I think. 4 z1 z3. Okay. So I've written it wrongly. Okay. So this will be 4z2 by z2 square, and this will be z1. Okay. 4z2 by z2 mod square is 4. Okay. Similarly, this will be z1 mod by 1. So these will get cancelled, and you will get 6 into mod of z1 plus z2 plus z3 conjugates. So sum of the conjugates is equal to, you can write z1 plus z2 plus z3 conjugate, and that is given, right? z1 plus z2 plus z3 conjugate. Okay, so that is equal to 1. Okay. Okay, so everybody clear? Okay. So what is our next problem? Area of triangle. Okay. Now, how do you find the area of triangle? We'll go to that now. So area of triangle, this is the problem. So let's look at the problem. There is no new concept here, but this concept of area of triangle you would have already seen in determinants. Okay, so the same concept you are going to use. Okay. It's 14, I think. So the area of the triangle formed by the vertices z, iz, and z plus iz is 50 square units. Find the value of z mod. Okay. So I'll give you a clue for this. So let us put z equal to x plus iy. So then, so we can represent it as a point in the Argand plane. Okay, in the xy plot, you can plot these points. Okay. So z is x plus iy. Then iz will be what? Ix plus I square y is equal to, so Ix minus y. So we can write it as minus y plus Ix. And z plus Iz is what? X plus Iy minus y plus Ix. That means x minus y. So we group, right? Plus I into x plus y. So z equal to alpha plus I beta plus z plus 2, z plus 4. I don't know. Let me come to that. Okay. So z plus, these are the three coordinates, right? Z, Iz, and z plus Iz. Then these are the values. So if you try to plot it, it will be something like this. So x comma y will be here. One point is x comma y. Other point is minus y comma x. So minus y comma x will be somewhere here. Other point is x minus y comma x plus y. X minus y, it will be a smaller number. X plus y will be a bigger number, right? Something here. X minus y comma x plus y. Okay. So now we know the three coordinates of a triangle, or three vertices. Three vertices of a triangle are, one is x comma y, other is minus y comma x, third is x minus y comma x plus y. This is what is given. So when we are given that the three complex numbers area formed by these three complex numbers, so we can translate it to the three vertices in this manner. So once you know the three vertices of a triangle, how do you find the area? Bhupesh, you raised your hand, right? So can you tell me what is the formula for area of the triangle when the three vertices are known? Bhupesh or anybody else? When the three vertices are known, half into base into height. So here, what is base and what is height? You don't know the base and height here, right? You only know the three vertices. Anybody? Who is the 12th class student? The determinant method. Yes, G Tamil. Yeah, determinant method. So what is the determinant? Area equal to half into determinant 1, 1, 1, then x1, x2, x3, y1, y2, y3. x1, y1, x2, y2, x3, y3 are the three vertices. Then area is given by half into determinant of this determinant 1, 1, 1, x1, x2, x3, y1, y2, y3. So you simply put that half into 1, 1, 1. What is x1, x2, x3? X minus y, x minus y. Yeah. Similarly, y, x, x plus y. These are the three y coordinates. These are the three x coordinates. Okay. So now solve this determinant. Calculate the value of the determinant and see what you get. 50 square units. Find the value of z. Okay. So this is given as 50. Okay. So this determinant is half into, let us see, 1 into what elementary operation can you do? Add these two. It's not coming, no? You can do that elementary operation also, but I'm simply calculating. Okay, you can make just 1 y by x and all will come, right? See, this is simple to evaluate as such. Okay, so you put minus y into x plus y. Okay, so that is the first one. 1 into minus y into x plus y minus x into x minus y. Minus 1 into second one, x into x plus y minus y into x minus y. Third one, plus 1 into x into x, okay, minus y into minus y. So that is x square plus y square. Plus 1 into x square plus y square. So it'll all get simplified actually. Half into 1 into minus xy minus y square minus x square plus y square. Then minus 1 into, sorry, this is x square xy. Okay. Second one, minus 1 into x square plus xy minus xy plus y square. Third one is plus x square plus y square. So here this you can see that x by xy get cancelled. Here also x by xy gets cancelled. So what you get is half into minus x square minus y square. So this is again minus x square minus y square, because minus 1 into x square plus y square, right? So this is x square plus y square. So 1 x square y square gets cancelled. Okay. So this modulus, area is a positive quantity, right? So you have to only take the modulus. So this is equal to half into x square plus y square. Okay, modulus of minus x square minus y square, because both are positive quantities. So we can take it as half into x square plus y square. But we know that this is same as the number is x plus iy, right? So this is your mod z whole square. Mod z whole square is x square plus y square. So and this is given as 50. Right? Area is equal to 50. So find mod z. So you can now find out mod z as mod z square equal to 100, right? Half z mod z. Okay. So we can you get mod z as 10. So this is how you use, the complex number, to translate it to vertices and use the vertices approach to calculate area of triangle. So did everybody follow? Yeah. Can you speak out, G Tamil? What is your name first? What are you typing? I can't follow. Jiva. Okay, Jiva. Yeah. Jiva. So can you speak out? You have any issue with your mic? Can you speak out otherwise? Network issue. Okay. What are you saying? Elementary operation. So this is another problem that you are having. Oh. Z equal to alpha plus I beta, Z plus 2 equal to Z plus 4 into 1 plus I, then alpha plus beta and alpha beta are roots of the equation. Which equation? What is the difficulty in this? Z equal to alpha plus I beta, right? Mod of Z plus 2 equal to Z plus 4 into 1 plus I. How to find Z, sir? Okay. So you can find out, no? See, Z equal to alpha plus I beta, right? So what is z plus 2? Simply keep substituting. You get alpha plus 2 plus I beta. Right? That is z plus 2. So what is mod of z plus 2? Equal to square root of alpha plus 2 the whole square plus beta square. That is where z plus 2, mod of z plus 2. And when that is given as equal to z plus 4 plus 4i. No, I think this is mod or simply, what is again no problem? This is mod and this side is it should be mod, right? Mod of z plus 4 plus 4i. Then we can try to relate alpha and beta and try to find out the relation between alpha and beta. Suppose this is mod. Okay. So then this can be written as again x plus okay. So then here you are getting alpha plus 2 the whole square plus beta square So what is the question? Is alpha and beta are roots of which equation? Wait. Can you check the problem? Is it mod of z plus 2 is equal to mod of z plus 4 plus 4 into 1 plus I? Is that correct? It's given mod of z plus 2 equal to mod of z. Z plus 4 plus I, 4i. And z is equal to alpha plus I beta. So this is what you get, right? So you can, this is a quadratic equation, so you can solve for alpha and beta from this. So alpha square, beta square will cancel. So what you get is Right. So it is not solving. So it should give some relation like alpha by beta, from this equation. Okay. So we can try to express alpha and beta in this equation. So then we can find out which alpha plus beta and alpha beta we should be able to get from this. I think there is some information missing. Yeah. Yeah. Tell me, G. Yeah. Jiva. I'm not sure if this problem I got it correctly. Okay. Okay. So you please send that to me later. Okay. It's the exact problem. You can just copy and send it to me. I'll help you to solve this problem. It should be a simple relation. Okay. From I think the problem I'm not getting completely from whatever you have given. Okay. So let's go to whatever we have in our agenda. Okay. So let me go to the next concept. So we saw the triangle problem, right? After that, let's look at how the complex numbers can be used to solve geometric problems. Okay. So this is one such problem for finding out the equation of a circle. $15, right? No, 15. Right. So how we can represent the equation of a circle in terms of complex numbers? Okay, we saw that the complex numbers can be represented in organ plane, right? Plotted as points in a plane. So now, if suppose this is one point, x0, comma y0, okay, which we represent as z0, okay. So then equation will be, let us say this point is x1, x comma y. Okay. So a circle will be equidistant from this point, right? So any point, the modulus of the line connecting this xy and x0, y0 will be constant. Okay. So that can be represented as modulus of z minus z0. Okay. So this is your z, which is x plus iy. Z0 is its x0 plus iy0. So then this is a constant, and that constant is your radius. So this is the equation of a circle. Z minus z0 mod is equal to r, and its center is z0, that is x0 comma y0, and radius is r. Okay. So if you can express this, so you can see from this problem, what does it say? Modulus of z minus 2 minus I equal to 3. Okay. So let us represent it in the standard form, modulus of z minus 2 plus I. You can write it like that. So you compare it with this z minus z0 equal to r. The center is 2 plus I. Therefore, center is 2 plus I means 2 comma 1, or we can write as 2 plus I is a complex representation. This is your geometric representation. Radius is 3. Okay. So the other way of doing it is we can convert it into normal equation in terms of x and y, and then also you'll get the same answer. So because, for example, this z can be written as x plus iy, right? Minus 2 minus I mod equal to 3. I into y plus 1, right? Iy minus 1 into y minus 1. X plus 2 plus I into y minus 1. So that is equal to 3. So, and what is this? This is x minus 2 whole square plus y minus 1 whole square root equal to 3. So if you square on both sides, you will get x minus 2 whole square plus y minus 1 whole square equal to 3. So this is equal to the circle with center equal to 2 comma 1 and radius equal to 3. Okay, because this is x minus a whole square, x minus h, right? X minus h whole square plus y minus k the whole square equal to r square. So instead of doing it this way, you can solve it more easily or more, with fewer steps, using complex numbers. Okay, so this is one, simple application of complex numbers. இது எல்லாருக்கும் புரிஞ்சுதா everybody? So I think I was sharing the wrong screen, okay. Wrong tab. So okay. So we can simply solve it as z minus z0 equal to r is the equation. So z minus 2 minus I mod equal to 3 can be written as z minus 2 plus I equal to 3. So that means the center is 2, the 2 plus I is the center and radius is 3. Okay. So I've done the same thing using x and y coordinates. So you are getting x minus 2 whole square plus y minus 1 whole square equal to 3 square. Okay. So again, that the way we write in terms of x and y, that is a Cartesian equation, and a simple equation in the complex form can be expanded to a slightly longer form. Is in Cartesian format, it will be a little longer. So we can convert one form to other, like just now I did for the circle. Adhe mari ninga either we can convert this Cartesian complex equation to a Cartesian equation. Okay. Let's do this problem. Obtain the Cartesian equation for the locus of this equation z equal to x plus y when z minus 4 mod equal to 16. So this is what is given. Z minus 4 equal to 16 is what? Is a circle, right? So what is the corresponding Cartesian equation? So can you solve this? What is meant by locus? Locus is like a equation. Okay, the relation, the path traced by the z equal to I plus y, I plus x plus iy, right? When z minus 4 equal to 16, what is the path traced by this z, okay, that satisfies this condition? Z minus 4 equal to 16, mod of z minus 4 equal to 16 is a condition, okay? So what is the path of the all the points z that satisfy this condition if you take? So that is called the locus. So locus you can think like equation in analytical geometry. Okay. So now it is given that z minus 4 equal to mod of z minus 4 equal to 16 and x plus z equal to x plus iy. Now write the corresponding Cartesian equation. Okay, z minus 4 mod equal to 16 and z equal to x plus iy. So then what is the corresponding equation in Cartesian format? So you simply substitute. That's all you have to do. So what you get is z bela x plus y iy minus 4 equal to 16. And this is same as x minus 4 plus iy, right? So and this is the real value, this is the imaginary value. So it is going to be x minus 4 whole square plus y square. That is the mod, right? Mod of x minus 4 plus iy is x minus 4 whole square plus y square. Root of x minus 4 whole square plus y square. This is equal to 16. That means square on both sides, you get x minus 4 whole square plus y square equal to 16 square. So this is the corresponding Cartesian format. Okay. So you can see that this represents a circle with center equal to 4, 0 and radius equal to 16. Okay. So you can actually, if you are smart, you can look at that first equation z minus 4 mod equal to 16 and see that radius is 16 and the center is 4, 0 because it has got no imaginary component. So only real component is there. So z minus z0, right? Z0 equal to 4 in this case. Okay. So therefore we know that the center is 4, 0 and radius is 16. Right from the beginning, just by inspecting, you can write it down. So once you write this down, then you can write the equation of the circle as x minus 4 whole square plus y minus 0 whole square equal to 16 square. So instead of doing all these steps, like simplifying mod and all that, you can simply write it off like this. Okay. So did you all follow? Okay, good. I think it is time now. We could solve a few problems, understand a few concepts. There are more to learn. Let's see. Can we continue for some more time? I think we are. We saw that area of triangle. We saw complex form of equation of circle. So now let's look at polar form, and then after that we can stop. Okay. So what is the polar form? Argument is the modulus we already saw. Argument is the only new concept that we are going to see now. Okay. So we saw that let us say there is a complex number z equal to x plus iy. Okay. So this can be represented as a point x comma y. Then this particular point can also be expressed in terms of this is your r. Okay. And this is your theta. So in terms of r and theta, we can represent x and y. So we can see that if this is r and this is theta, this will be r cos theta and this will be r sin theta. Okay. So x equal to r, this is the relation, x equal to r cos theta and y equal to r sin theta. Therefore, this z will now become r cos theta plus I into r sin theta. R into cos theta plus I sin theta. and r equal to root of x square plus y square. That is the modulus. Okay, so that also we know. Now r equal to root of x square plus y square or mod of z. And theta equal to, we can see that theta is represented by tan theta equal to y by x, or theta equal to tan inverse of y by x. Okay. So this is the polar representation. This representation z equal to r into cos theta plus I sin theta is called the polar representation. We sometimes write it as r cis theta to represent cos theta plus I sin theta. We write it as r into cis theta. Okay. Now there are a few more concepts, but I want to explain it using a problem. Okay, we will take up a problem now. One problem we will do, and then we will stop for the day. Okay. Okay. Now write 3 minus I root 3 in polar form. This is our problem number 17, I think, 18. Okay. Now I will do this problem and I'm going to ask you to do the next problem. Okay. So this is z equal to 3 minus I root 3. Right? So what is your x? X equal to 3 and y equal to minus root 3. If you represent z in terms of x plus iy, x equal to 3 and y equal to minus root 3. Now, what is r? So in polar form means you have to get it in terms of r and theta, right? What is r? R equal to 180. No, r equal to square root of, right? No, I'm talking about r. R is the modulus, right? Correct? 3 square plus root of 3 square. Okay. X square plus y square, right? Root of x square plus y square. So x is equal to 3, y equal to minus root 3. Minus root 3. I missed that. Okay. 3 square plus minus root 3 square. So that is 9 plus minus root 3 square is also 3. Plus root 3 square or minus root 3 square, both will be 3 only. So that is root of 12, which is same as 2 root 3. Okay. Because the square root of 12 is square root of 4 into 3. Square root of 4 is 2. So 2 root 3. R equal to 2 root 3 now. Now let's get theta. To get theta, there are some negative signs also. So you have to be careful. Okay. So how to calculate theta, I'll tell you. First thing, we have to calculate something called the alpha. Okay. So alpha is the angle in the first quadrant. Okay. So that we first determine by, tan inverse of modulus of y by x. First, we have to calculate the alpha value in the first quadrant using this formula, tan inverse of modulus of y by x, which is tan inverse of. So forget about all the signs. X is 3, y is again just root 3. Forget about the sign. Okay. So that means y by x. So ignoring all the signs, you calculate this. This is called alpha. Alpha is the angle in the first quadrant. Okay. So and that will be tan inverse of 1 by root 3. Yeah, root 3 by 3 is 1 by root 3. Wait. We'll come to that, G. We'll go step by step. Okay. I want to make sure that everybody understands first. So tan inverse of 1 by root 3 is what? Let other people say. Tan inverse of 1 by root 3, 30 degree. What about other people? Bhupesh, Krishnaveni, Sumit? Do you know tan inverse of 1 by root 3? Can anybody say?
Pi by 6.
Correct. 30 degree or pi by 6. So we normally represent it, in complex equations. We, in the, polar form, we write it in radian form, pi by 6. Okay. But what G said, Jiva said 30 degree, that is also correct. 1 by root 3 is pi by 6. Okay. Alpha, once you determine alpha equal to pi by 6, now this theta is the principal angle. The theta can be, if you see, this angle, or make one whole round and come to this angle 2 pi plus theta, or 4 pi plus theta, 6 pi plus theta, that is 2k pi plus theta. It can be anything. Okay. But the theta first we'll have to determine. Theta can be in the first quadrant, second quadrant, third or fourth quadrant. But now looking at this, z equal to 3 minus I root 3. Which quadrant is this theta lying? Which quadrant is it? Second. Is that correct? X is positive, Y is negative. Which quadrant is this?
Third quadrant, sir.
Krishnaveni is correct. Third quadrant, both are negative, right? X is positive, Y is negative, means this is fourth quadrant. You have to be careful. Okay. This is fourth quadrant. There is this angle of 30 degree or pi by 6 in the fourth quadrant is what we should take. Okay. This is your theta. So therefore, in this case, theta will be minus pi by 6. Okay. So if it is in the second quarter, we represent this angle going from into the positive. What is the positive and whatever angle that comes from the x-axis up to this. If it is negative, so we calculate minus of, in the third and fourth quadrant, we calculate it as negative of 0 to pi. So for the first and second quarter, it is positive 0 to pi. Zero to minus pi. So this is the way we should represent the theta. 0 to pi or 0 to minus pi. So depending on which quarter it is. Okay. Oh, so in this case, it is in fourth quarter. So we represent as 0 to minus pi and in the anti-clockwise direction. So it is pi by 6 in the negative direction. So it is minus pi by 6. So theta is minus pi by 6. So what is the polar form then? R into cis theta plus 2k pi. I told you, why the 2k pi comes. Because as many 2 pi's you can keep on adding. Okay, the point is again it's going to come back to the same point. Therefore, the polar form, we have to, this is a complete solution will be R cis theta plus 2k pi. Any one of them is R c, where k equal to 0 to any integer. K is integer. Okay. So any integer, this will be valid. So in this case, therefore, your theta is R is what? 2 root 3. Therefore, polar form equal to 2 root 3 into theta is minus pi by 6 plus 2k pi. This is all. Okay, this is how we should write it. Okay. Now do one more problem. So hopefully you will understand this better. It's very, very basic and important to know this, converting from a rectangular to polar form, because once you get it into polar form only, you can apply, certain theorems like the De Moivre theorem. So any number you should be able to comfortably convert from rectangular to polar form. Now I give another problem. Okay, similar problem. So please do it now. Okay. -2 minus I2. This is our problem number 18. Right, -2 minus I2 in polar form. Alpha 1. We did one problem just now. In the same way, you have to do this problem. So I am giving you a minute. All of you, please do. Yeah. So what is the value of R in this case? Two root 2, not 4. Okay, because it is root of 2 square plus 2 square, which is 2 root 2. Okay. Now what is alpha? Very good, Krishnaveni. Yeah. Jiva, you need to be a bit careful. Okay. Alpha is pi by 4. Very good. Alpha is the tan inverse of modulus of 2 by 2 minus 2 by minus 2. So it is again just 1. So tan inverse of 1 is pi by 4. So alpha is pi by 4. And which quadrant is this? -2 minus I2?
Third quadrant.
Third quadrant. Very good. Third quadrant. So pi by 4 is your is alpha, right? Alpha equal to pi by third quadrant. So then what will be your theta?
Alpha minus pi.
Right. So this is what is minus, we have to put it right. Minus of pi minus alpha. This is your alpha, right? So this will be minus of pi minus alpha or alpha minus pi. So in third quarter, you always write it as alpha minus pi. Second quarter, you write it as pi minus alpha. First quarter, you write alpha itself. Okay. Third quarter, it is alpha because it is minus of pi minus alpha. So this is minus alpha. Fourth quarter. In this case, it is alpha minus pi. That means theta equal to pi by 4 minus pi, which is
Minus 3 pi by 4.
by 4. Very good. Minus 3 pi by 4. So that is where theta. So therefore, the number z equal to r, which is root of 8, or 2 root 2 into cis minus 3 pi by 4 plus 2k pi. Okay. 2k pi plus minus 3 pi by 4. Correct. Very good. That's right. Krishnaveni, that's correct. Okay. 2 root 2 cis 2k pi minus 3 pi by 4. Okay. So I think it is getting late now. So we'll stop now. We'll continue with more problems and demo.